We are going to place these numbers in order from least to greatest. I'm going to change them from the fraction version to the decimal version. This would be 4/10 if we doubled the top and the bottom. So you can rewrite that as 6.4. 3/10 is 6.3. 3/4 is worth 75 cents. 7/10 could be written as 0.7. And 15/100 is 0.15. So now I can put them in order. I'm looking for the smallest value in the tenths place, which in this case is a 1, so that is 6 15/100. Then the next smallest value in the tens place would be 6.3, or 6 3/10. Then we have 6.4, which was 6 2/5. 6.5, which is 6 1/2. Then between these, they both have a 7. So I can look at the next digit, which in this one is a 0, and in this one is a 5. So 6.70 is smaller than 6.75. So we're going to write 6 7/10. Then 6 3/4 is the largest. Please place your remaining problems in order from least to greatest. A school cafeteria manager notices that he does not always get the same number of baby carrots in a bag. He counts the number of carrots in each new bag he gets for 2 different brands. The dot plots display the data sets he collected. The mean is marked in each dot plot with a triangle. Do you think that the mean is the best measurement of the typical number of carrots in a bag? Because this data is skewed, and this one is skewed right, because more of the data is to the right than to the left of the, or extends farther to the right than to the left of the mean. And this one would be skewed left because it extends farther to the left from the mean than it does to the right. In a skewed data display, mean isn't necessarily the best way for us to measure what's typical. Today we're going to look at another method called the median. So it says find the middle dot of the data distribution. The way that I do this is I cross off the same number of dots from both sides of the data distribution until I find the point that's left in the center. So far I've crossed off 5 from each side. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 from both sides. And that left me with this dot right here at 41. So the median is equal to 41. That is the middle dot if we eliminate the same amount of dots from both sides of the data distribution. In problem 2, we have another data distribution for brand B. We're going to do the same type of process. Now you'll notice if I cross off these last ones, there won't be any dot left to count as the center. So I look at these two dots that remain, and I need to figure out, well, if there's two dots left in the middle, what would be between those two dots? What is between 51 and 53? That would be 52. So in this case, when we have an even number of dots, and we try and cross off one from each side, we're going to be left with two dots in the center, and we'll find the average of those, which is 52. So depending on if you have an odd number of points or an even number of points, this process might look slightly different. All right, let's consider these statements and determine which ones are true. Half of these bags have more than 52 carats. Well, there were 17 bags to the left of 52, 17 points on this side, and 17 points on this side, which would mean half of them do have more than 52. Half of these have fewer than 52. Well, yeah, 17 of them had fewer than 52 carats. More than half had more than 52 carats. This would be false. They're the exact same amount above and below 52. And lastly, if someone got a random bag of carrots from this group, the bag could have as many as 57 carrots. If we look at the dot plot, there is in fact a dot at 57, so it could get up to 57 carats. That is true. Number 3. Kelly is curious about the typical number of seeds in an apple. She finds the following numbers of seeds in 11 different apples. Find the median number of seeds. Mark the median by drawing a vertical line segment through the middle of the data set. So for the median, we want the same number on each side. Let's see, if I did 4 here and 4 here, looks like I still need to go further than that. How about putting 5 on each side? Then the middle number would be that 7. We could cross off 5 from each side. And we would see that the middle lands us at that center 7. Kelly is curious about the typical number of bananas in a bunch. She finds the following number of bananas in 14 bunches. Find the median number of bananas and mark the median by drawing a vertical line segment through the middle of the data set. If there are 14 bunches, that means we could put 7 numbers on each side. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, what's in the middle of 4 and 5? What's in between those two values? That would be 4.5. When our line lands on a number, that's the median. But if it's between two numbers, we have to figure out, well, what's in the middle of those two values? The dot plot and the data set show student scores on a 6th grade science test. A. How many scores are in the data set? Well, we can count the points or we can count the values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. There are 28 scores in the data set. B asks, how many scores should be located to the left of the median and to the right of the median and explain. Well, if there's 28 and the median is the middle, we would want 14, because that's half of 28, to the left, and 14 to the right, because it represents the middle. Oops. Find the median score. Oh. Mark the median by drawing a vertical line segment through the middle of the data. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's going to be in between these sets of points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there's the same amount on both sides. Our points here are on 80, and the points here are on 85. So what's in between 80 and 85? If you're not sure, you can find the average, or the mean of those two numbers by adding them up and dividing by 2, just like you would to find the mean. And that gives us 82 and a half as our median. And then it says mark the median by drawing the vertical line segment through the middle of the data set. So 81, 82 and a half. Suppose a student whose score was recorded as 64 actually scored 71. The dot plot shows the new data set. Does the median change? Well, we had our median here, and it moved from 64 up to 71. But it still remains on the left side of the median, so there's still 14 points on the left. So no, the median does not change. Because it remained on the left side, it did not change where the median was. Suppose a student whose score was 64 actually scored 89. Well, in this case, it went from the left side over to the right side. So this would change where the median is because it's moving that point. So now there'd only be 13 on this side and 15 over here. So yes, the median would change in this circumstance. Tyler is curious about the typical number of pages in the books he has read. He records the following number of pages for all of the books in his collection. Now, he might be tempted to say that 75 is the median, because that would put 1, 2, 3, 4, 5, 6, 7, 8, 9 below it, and 1, 2, 3, 4, 5, 6, 7, 8, 9 above it. The problem here is that Tyler does not have his page numbers in order from least to greatest. You can see there's 83s above and below 75. So before we can find the middle value, we have to start by placing the numbers or the values in order from least to greatest. So in this problem, it says Tyler's older sister Lisa is also curious about the typical number of pages in the books she has read. Lisa records the following numbers of pages for all of the books in her collection. Organize the data set by using the frequency table. So we're going to create a frequency table for these numbers of pages. Our lowest value that I see is 175. And we'll go up from there. So there's a 180, 179, 177, 178, 178, 180, 176, 77. How many books are in Lisa's collection? So we have 2, 3, 4, 5, 6, 7, 8, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. Oops, I put that in the wrong spot. What is the median number of pages in the data set or for the books? So if we had 26, that means we would need 13 on each side. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's going to fall right here. There would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 on the upper side and on the lower side. So in between 179 and 180 is the number 179 and a half. And that takes care of lesson 12 on the median. It's important to make sure that they are in order from least to greatest before you start to find the middle value.